Hey, good. Math self-efficacy.
Hope this quiz is 10 or less questions.
It's 15. So, hello. I know. All right, so we got math efficacy. So score. Okay, so that's interesting. That now we're dealing with. Okay, well, what we're going to figure out now is with this amount of confidence, that typically means that your score is this, and with every increased number of confidence, that would generally say that your score is increased by this much. That's what we're trying to figure out now. So the X would be confidence and the Y would be the score, is my guess. But we didn't do that last time, but I think it makes. Shoot, hold up.
Hello.
Herman, welcome.
Hi, Herman.
Hi.
Okay, so we're already in the quiz. If you want to open it up.
Okay. Where are you at?
Number 0. Well,
number 0.
That's.
I did 1 and 2.
That's good.
So
and maybe more.
Would you say that the explanatory variable would be the confidence? Well, hold on. Let me read. Shane Goodwin and other researchers studied factors that affect a student's confidence in a multiple choice mathematics exam. The exam consisted of 30 multiple choice problems worth a total of 100 points. Each question, the students evaluated their confidence in their response. Confidence ratings were not related to the instructor. The mean difference, the confidence rating mean. So which one do you think is the explanatory and which one the response?
Hey,
which one are you taking?
What?
The math self-efficacy.
Where are you at?
Oh.
Is this
Math 221?
221.
221.
What?
Oh, I can't.
This is the same.
Different.
This is the same data we used last time.
Hey, I'm lost.
2.0.
Hold on.
It's 2.0.
Okay, hold on. Oh, never mind. I thought we already had to plug stuff in. Yes, Y is 2.0.
2.0.
Sorry, I was getting way ahead of myself.
You just have to look
I know, that's why I was like, where are you?
You have to look at the equation, don't you?
So I thought it said, you will need the following data set for the following questions. I didn't finish that sentence. It just ends right there. So linear regression equation, y equals 2.0 plus 1.5x. What is the slope?
1.5.
2.0.
1.5.
1.5. It means up 1 over a half.
1.5.
Okay, 1.5. Right?
Right.
Yep.
Yeah. In the beginning, I was like, what is Greg talking about? I was lost in the beginning.
Me too.
I think in general, it's okay because I'm lost even when I'm talking.
Okay. Okay, question 5. Should I read?
Yeah, read.
Yep.
Okay, given the linear regression equation y equal minus 3.0 plus 0.25x, what is the predicted value of y when x equals 16? And we'll have here, just put 16 in the
Yep.
x, and it will be 4 minus
Minus
3 will have 1.
Yep, that's what I got.
Okay.
Are you talking about 5?
Yeah.
Okay,
What
now,
did you get?
okay.
What did you get, Tiffany?
I guess I was looking for the wrong thing. I got 4.
Yeah, that's 16 times 0.25, but we're solving for y, so you have to continue to solve the problem. So it's 4 minus 3.
Okay. I just didn't finish it.
So you get 1?
Okay.
Yeah.
Yeah, it's 1.
1. Okay.
When you get 1, you try to do many times to see if it's right or not. But it's right, it's 1.
Okay. I trust you, Herman.
Not a good idea.
It's like you didn't do anything when it's 1.
Okay. So
Okay.
we have to determine then, because x is the explanatory and y is the response. Now, I'm confused because did we not read on Tuesday that they were interchangeable, that they could use one or the other?
No,
Okay. I thought we read that. So
I don't remember.
according to this week's reading, then, the explanatory has to be what the response variable is based off of. So in other words, the one that they use is, if the alligator's head is this big, then the body should be this big. So the should be is the response variable. So
Right.
so in this, which one would be the explanatory, the score or the confidence rating? I think they're in order because what they're testing for is the confidence rating compared to the score. But it says,
Are you talking about number 7?
we're talking about the math self-efficacy. It's the Excel spreadsheet that we're using. So
okay.
So I'm going to copy and paste the score into the explanatory and the confidence rating. Control copy into the response.
The second column.
Okay. So everything in the next 7 questions is based off of us picking that the right way. Okay. So the first question is, oh my gosh, seriously? Make us gather play. Hot dog, hamburger, or banana? That is the dumbest explanation.
It's hot dog.
I think it's a hot dog too, but you could easily say that it looks a bit like a banana and a bit like a hamburger at the same time. I don't know what kind of hamburger. And also, that question isn't really fair considering that what if they don't even have hamburgers down in Zimbabwe? Or wherever, sorry. Not Zimbabwe.
Yeah, but that's what it says in the book.
Mine looks like a pizza.
I found hot dog.
I think it looks like a huarache, so now what?
I think we're at a pass.
Or a machete, you know what I mean? That's just food from Mexico City.
Looks like a machete.
Okay.
Hey, no. What did you get?
I put hot dog.
Hot dog.
And for what it's worth,
like the most?
What?
Hamburgers.
Hamburger?
My Excel is easy. It's, ¿cómo se dice? Congelado.
Frozen.
Frozen, like so?
Yeah.
What-
That's congealed, by the way, if you translate directly, congealed. Congelado. That's okay. So
Hot dog?
by the way, would you say this is a positive or negative? And is it strong or weak?
It's positive, but
I would say
depending on the number, I mean, I'm trying to find where the.
I would say positive and strong because it's positive and they're all lumped pretty close together, and they're all moving. They're all.
It depends on how close it is to 1. If it's strong, it's greater than. It has a 0.7 or greater.
Wow. Oh, that's right. 0.7 is the R. R is 0.728. Yep. So, okay. So based on this, then number 7 says, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model this data? Okay, so the y is not negative, and the slope is not, well, it doesn't matter if it's negative or positive, but the y is not negative. And the appropriateness was when it was saying like, well, when x equals 0, then y is negative 20. And that's not appropriate. That doesn't make any sense. So then you could say simple linear regression is appropriate for these data.
A.
Number 1.
Yes.
I think so.
Where are you at? I am back. I was lost. I was out.
And now,
You're out.
you're
For 7.
Number?
So I didn't understood if what you saw was a banana or a hot dog.
I don't know. The scatter plot.
Yeah, you have to see how it looks like.
It looks more like a left footprint to me. Where's that? Can you like enter in what do you think it looks like? This is just an interpretive quiz.
Can you share
for like psychology?
Can you share your? Yeah, I can't see my plot.
So here's mine. If you go to the book.
Are we talking about hot dog with or without the bun? Okay.
Right here.
Oh, okay.
Definitely a hot dog shape.
This is what we're looking at. This is our. So it's definitely hot dog.
In that case, if the book says that that's the shape of a hot dog, that it is.
There you go.
That it is.
Okay. So how many observations in the data?
Muchos.
Oh, that.
Yeah, you can put that down. Tem muitos.
139.
139. Okay. What's the y?
Are we timesing that by 2 because we have 2?
Y-intercept is 1.296.
Wait. So observations, is that both columns added together or is it just one?
I don't know. Good question. Let's go to the book.
Observations are from the same explanatory variable. I mean, they are related. Both columns are related from the same.
I don't think it's both columns, but I have nothing to substantiate.
For response variable. 1.296.
1.296.
That's number 9, right? And number 10. Oh, we are number 10, right?
Number 9.
The y-intercept.
Yep.
And what is the slope? 0.042. Which means for every 1 unit, so in other words, for every 1 point that the test score increases, the confidence level of the students goes up 0.042, right? So every 1 it goes over slightly, or no, every 1 it goes up slightly. One of those two.
Okay.
0.04 is what you get in number 10.
0.042.
Oh, 3 decimals. Yep.
I got 1.46.
The slope? Is there an equation for the slope, or do we put down the slope?
No, I'm talking about 11.
Oh,
I got 0.42 for 10.
Okay, so if x equals 4, because y equals 1.296 plus 0.042 times 4. Is that what you got? I mean, is that the equation that you got?
Currently, I did 4 times 0.042 plus
1.296. So I got 1.464. Is that what you got?
Yep.
Okay. Are you following along, everybody?
You can't hear me?
I can hear
No,
you.
I
I can hear Herman.
Oh, Herman. Maybe Herman is
I can't hear.
out.
What number are you on, Edgar?
11. But I don't know what's happening with my quiz. It's not saving my answers. I don't know if
It's not saving them? Weird. Okay, so the confidence data resulted from students of number 12 evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x?
Yeah, we can hear you now.
Okay, I am behind, and the internet here in Mozambique, it's not really good, and you got 139 for the number of observation. How did you get this number?
We didn't get 179. We got 139, right?
139.
39.
But how did you get
You want me
that?
to share screen?
Yeah, share screen.
Okay, hold on.
Can you show me?
Oh, yeah. Can you see my stuff? Okay, let's see. Where'd I get it? Down here. All right, here. It said a group of n equals 139 students in the intermediate algebra course took the BYU Idaho participated in the study.
Okay.
But if you also go down here, they start on row 2, or if you look at the count down here, it says 139.
You have to make 142 minus 2. Okay. 139. And I stopped in that question before I got lost. Okay, number 9, the y-intercept.
So on the table, this BO y-intercept.
That
right there.
one, it's 1 point. Okay.
296.
1.296. Okay.
Okay, so.
And then the slope is
And
that
the-
number right underneath it.
Okay, the slope is down there. Okay.
So 0.042.
Yep. Did I miss something else?
Number 11.
No, we're on number 12 now.
Yeah.
1.
So number 11
4.
times 4 times this, and then add it to this, and you get 1.464 for the predicted value of y.
Okay. Sorry. Can you explain again really fast?
So 4, when you plug 4 in for x,
Here, let
it's
me
4
Yeah.
let me write out
times. Okay, go ahead.
So, okay, in this equation, hey, so Herman, do you have the t-test for the linear regression? Do you have that up?
The app for t-test?
No, not the app. Did you open the Excel spreadsheet for the, it's under quantitative inference procedures. We have the t-test for linear regression. Do you have that done? Okay, so I'll show you. So what we're doing here is y equals, I forgot what he said, b, whatever the 0 was. Okay, this is the, can you read this b dot, is that what he said?
Yeah, okay. Y equal b, the b0 is the y-intercept.
Yes.
And b1 is the slope.
Yes.
Yes.
And so x is whatever number you put in there. So it's giving us 4 as x.
This
so then
is
you
the thing we did in the previous question almost.
Yes.
Okay.
So you're just basically solving the equation.
So
and they are already giving us
what?
We have the slope, and if we have the slope, we can calculate the y.
No,
Okay.
yes. So you're solving for y. So it's this one right here where it says y
equals 4.
1.296 plus 0.042 times 4. You solve for that, okay? Now, that's how we got 1.464. The next one says the confidence data resulted from students evaluating their confidence for each question on a scale from 1 to 6. What's the maximum predicted value of y? So in order to do that, you have to get the highest x in the explanatory data, which was 100.
100.
So you input that as your X, and that way you can get your Y.
Wait,
What? Is that? I can't hear you, Tiffany. Are you saying something?
I'm confused. Okay, so
Look, read the hint. Read the hint.
because there is a positive correlation, we can use the largest X value to find the largest predictable Y value. And the
Now,
largest predictable
it's
X
not
value is
saying
6, isn't it?
it's not saying that 6 is the highest value, because it was. It's saying the highest predicted based on this equation. Because that slope can only move on that slope. So at that slope with 100, what would you have? Let me know what you guys got.
$4.2 if it's 100. Oh, I see what they're saying. Oh, okay.
In Costa Rica, they would say, "Ya se te cayó la peseta." You've now, the sky, the skies have parted, the sun has shone down on Tiffany. Just kidding. I don't even know if I really get it. We'll find out.
Because we're finding out what it's the maximum. What is the maximum predictable value of Y
Based on
these
this equation.
values of X?
Yes.
Correlation is it, or just X? So did you get 4.2?
No. 100 times 0.042 plus 1.296. Don't forget that. You got to add the Y intercept. Make sense?
5496.
5.496. All the good pickup sticks. Yep.
Okay. Just to be honest, I did not understand, but I can understand.
No. I don't like that. Let's figure this out. So it's saying we took the set of data with the explanatory, and then what was the name of the other one? And the response variable. Okay, so in the explanatory, that's saying, okay, the head of a crocodile is this long. So if the head is this long, the body is this long. So they're saying the relationship between the head and the body is that equation. So if the head is this long, that's the X. Enter that X into the equation, and the body should be this long. Okay, so here, the X is 100.
The highest X is 100.
The highest X here is 100 because that's the highest score you can get on the exam, and there are 2 of them, I think. So you enter 100, but 100 is the X, just like we did 4, but now the X is 100. So you times it by the slope first, and then you add that to the Y-intercept. So it's just the 100 is the X times the slope plus the Y-intercept, and that gives you 5.496. Now, I'm talking like I know what I'm doing, but until we hit enter, submit the quiz, we don't know. Yeah.
Okay, but how did you get that 100? My question is.
Okay, because it's
on the data.
On number 12, it says the hint is there's a positive correlation, so we can use the largest X value to find the largest predicted value of Y. So I used the largest x value, which is under the explanatory, it's 100. It's the highest
okay.
test result.
Did you download the document with the data?
What?
Yeah.
I'm asking him if he has the document with the data.
Yeah.
Scatter plot, and if you go on your down on your x-axis, that it has 3 100s. Bing, bing, bing.
Okay. That makes sense. But what did you get?
5.496.
Yes.
5
496.
496.
496.
Okay, 5.496.
Yep.
So it is this. 100 times the slope, which is 0.042, plus the y-intercept, which is 1.296. That's it. So y equals 100, and it's the same equation we used when they gave us the number 4.
Yeah.
Kind of weird.
What?
How many response variables are there and explanatory variables?
I'm kind of confused by this one, but reading my notes, it says an explanatory variable is used to predict the response variable, and the response variable equals the dependent variable or the y variable. Well, they're the same. It's 130 something. 139.
The option is more than that. More than
more than 2.
But they're asking in a simple linear regression.
Which is what this is.
Simple linear
Right,
regression.
which is one equation.
2.
But in this one equation, we took.
Okay, so in the equation, y hat equals b naught plus b1x. How many independent variables are there in there, and how many dependent variables?
Well, but this is it though. The y-intercept and the slope are not explanatory or response.
Right.
So it's more than 2 for both of them, because although the y, no, that doesn't make any sense. It has to be more than 2. See, no, it doesn't. It's saying in are present in simple linear regression. Oh, in general.
Yep.
Does it mean in general, or does it mean it doesn't? So it doesn't mean. Yeah, it doesn't mean in this one. How many explanatory variables are present?
As one problem. How many independent variables are there? How many dependent variables?
More than 2.
Let me look in the
lesson.
Yeah,
let's read the book. Yeah.
My computer's going really slow.
This is 22, yeah.
Yeah.
Where did you find that in the book, Greg?
There was the notes from the video that I was looking at. Predictions, interpreting the regression equation. Okay, so check this out. in the video under section 2.1, the video, it's an hour and a half long video of National Geographic called Super Croc, but it only had one skull. They only found one skull, but they were able to use this linear regression to determine how long the body length was of this. Well, they were able to hypothesize, right? How big they think that the body was based on the skull size, using the averages maybe from modern day crocodiles. So I think that the answer is probably are present. Well, why can't it say one or more? Like, I don't understand.
Okay. So if you click on the linear equation, review of linear equations, it says a linear equation is a technical term for any equation that describes a line. Two important characteristics of a line are the y-intercept and the slope. So there's only one of each.
So it'd be two then. Two, because one, they're saying that one is.
There's one.
So why would they use in the equation that one is explanatory and one is a response, when really that's that's how we categorize our data, not. That frustrates me.
So there's one independent variable and one response or dependent variable.
I think my problem is understanding the English.
Okay, how can we help you?
That I don't know.
You don't need to know what simple linear regression means. You just need to know. So when we started out, in my notes, there are two variables. There's explanatory and response. So the explanatory is saying everyone in Mozambique who's a male, if their ears are this big, then their heads are this big, right?
Okay.
So the if is the ear size, and then is the head size. So the if is the explanatory, and the then is the response variable. So if ear sizes are 5 centimeters long, then the head, but you see what I'm saying? That's the dependent variable is number 2. And that's what it's asking, is how many independent, meaning the first variable, are present, and how many of the dependent, or the second variable, are present. But in a simple linear regression, it's not talking about the number or the information that we got, the data in the Excel file. This is in general. And we don't, but it's asking about in the regression, but it isn't, you know what though? It's not saying in the formula. So how many variables?
It's saying in the simple linear regression, and it says simple linear regression is a method used to fit a line into data. This provides a powerful tool to model bivariate data, which is data involving 2 variables. To write a linear equation that models.
Yeah, so it's 2 variables. Okay, it's 2 variables, but it's only one of each.
Right.
So 1 and 1.
And 1 dependent.
1 independent and 1 dependent.
Right.
Yes.
It's like a single mom with 1 kid. Just kidding. Not to confuse you. Sorry. That's a tax joke. Okay. Then let's try that. Okay.
Okay.
Go from there. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, ear size of men in Zimbabwe. Weird. I mean, in Mozambique. Sorry. Lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. Okay, so the circumference is X and the size hat is y. So what is the response variable? It's the size of the hat.
Nice.
Because it's the variable being predicted. So it just says the company wants to predict the size of the hat given the circumference.
Because it's being used to predict circumference?
No. The circumference is being used to predict the size of the hat. So they give the circumference. Circumference means how big all the way around, but that doesn't mean the size of the hat. So the size of the hat, it just says in the last thing, the company wants to predict the size of the hat with the information, which is the circumference. So they want to predict the size of the hat using the circumference. Okay, I think it's the first one. Any other thoughts?
No thoughts.
Okay, and I'm going to save all responses, and I'm going to submit the quiz. So I posted it in the thing in my Word. So hey, how do you know? Do you know where all these responses are coming from, Edgar? Or no?
No.
Or random. Okay.
Yeah. And I was thinking that maybe I needed to include the country, so that they could choose a country where they're from. But I don't know if it's gonna be relevant for a study. In the let me
hold on, guys. Okay, we got 9, 10, 11, and 12 wrong. So I gotta get this phone call. Yeah, here, look. Can you see it?
What is that? No. What numbers?
9, 10, 11, and 12.
9, 10, 11, and 12. Oh.
So number 9's asking intercept. That's what it gave us. Intercept 1, 2, 9, 6. Confidence data for the example. Okay, so did I do that? Confidence, okay, I did that wrong. That's why, because they told us to do that. Write in the problem to use the confidence data as variable, explanatory variable. And then, oops. Okay. is going to be the scores. Still looks like a hot dog. Got that one right.
Hot dog.
Hot dog, yeah. 7 is correct. Number 9. 8.
The y-intercept.
So now it says 18.690.
18?
90. The slope is 12.695. .695. Okay. Okay, so now if we plug that 4 times 12.695 equals
plus 18.
50, right?
50 what? Sorry, I can hear you well.
Oh, sorry, 50.78 plus 18.690 equals 69.47.
Okay. Sorry, guys. So we figure out what we did wrong there?
Yeah. Put them in the wrong columns.
Well,
we put them backwards?
What?
If you read the opening question, it says, be sure to use confidence data for the explanatory variable and score data for the response variable.
Wait. Where's that?
Information for next 7 questions.
Oh, I feel so dumb. Okay.
69.47.
Yes. For number 11, 69.47.
What I got? And
number 12 is going to be different too.
Okay, so what'd you get for number 9?
Sorry.
So the y-intercept is 18.690.
Okay.
And the slope is 12.695.
Okay. So then 11, I can do that. 4 times 12.695 equals plus 18. So 69.47, right?
Yes.
11. And then number 12 would be 100 times 12.695.
We switched the columns.
You are totally right. So, dang it.
Did you get 1,288?
593.
No, it can't. It has to be under 100 because we're switching. It's backwards now. So we have to figure out what's the highest confidence level that we get. There's.
Oh,
Okay,
It's between 1 and 6, so it's 5. I think it's
Okay.
593.
I'm gonna arrange this here
Okay.
just to fit. I'm gonna. Oh, it's freaking A. Highlight.
6.
And then
It's 6.
sort smallest to largest.
what is the largest?
So the largest is 6. Yeah, so it's 6.
6?
Okay, so we do, so we do 6 times 12.695 plus 18.690. And that is 94.86. Is that what y'all got?
Yes.
Yeah.
86,
Hello?
Hey, Herman.
Herman.
Hey, my internet, it's not really good, and I'm so sorry. And okay,
Did you get all the corrections for
okay, we have to switch
9,
the
10?
column, don't we?
Yes.
Okay. And for, let me see, for number 9, I got 18.90. Is that right?
18.690. Sorry, go ahead.
690. Okay. Number 10, 12,695.
Yep.
Next one, 69.47.
69.47. Yep.
I got number.
Okay.
I got number.
Okay, we are in question 12.
$94.86.
0.86.
4.86.
Okay. Question 13 is 1. Yep.
Yes.
And the question 14 is 1 also.
Yep.
The last one, the circumference, because it is the variable being predicted.
Did you guys already submit, by the way?
Yes.
Okay, so we're all right then?
Yes. Size of the hat because the variable being predicted.
69.47, 12.695, 18.690.
Yes, we are right with those answers.
Okay.
Okay, for 15 is the circumference.
Mm-hmm.
No, the size of the hat because of the variable being predicted.
The size of a hat?
Right.
Yep.
If you read the last sentence says, the company wants to predict the size of the hat. So what is the response variable? It's the size of the hat. What you want to predict is the response variable. So, okay, I just did it again and got 100. Perfect. Okay, good. This week's been a good week so far.
So can you see my screen?
Okay, sweet. Okay, so I've got a couple responses so far, but we should have for the for our survey, we should have, how many responses did we say we were trying to shoot for? 30 each?
30,
I think
40.
30, 40, and we have 48 right now.
48. So who posted this?
I'm sharing the link with contacts and groups on Facebook.
Okay, I'm gonna actually put, I'm gonna see if I can't share it in a couple other groups and stuff, okay? So.
Yeah, I did too. I shared it in 2 different groups.
Okay.
If you can see my screen,
Yeah.
Here's the data we have collected. Creo una hoja de cálculo, crear. Let's see.
Let's see tu hoja de cálculo.
hoja de calculadora.
Con las horas. Wow, these are all today.
And we have the answers, numbers.
Okay.
So yeah, at the end of collecting the data, I will create some graphs. I think the assignment says that I need to create a graph describing like the insights of the data that we get. And
okay, so Edgar, on that, the teacher said that if we're doing, this is an ANOVA test, so if we're doing a graph, it's going to have to be a histogram.
Oh, okay. That makes sense.
Histogram.
Okay, guys, I got to get going. I don't want to be in trouble.
So if you help me to share that link, I think we need to finish this assignment by tomorrow, right? We need to send this tomorrow.
What do we have to send by tomorrow?
Yes. So if you can share that today, that would be very...
I already shared it. What do we have to have ready by tomorrow?
The graphs with describing the data and the summary of the data. I need to explain what we get by collecting these numbers. And I'm just gonna show you. This is the ¿cómo se dice? El documento.
The document.
Yeah. And it says state your research question. The question I stated was, does the number of people in your family influence the number of children that you decide to have? Is that okay?
No, that English is all backwards and makes no sense. I'm just kidding. It's perfect. It's perfect.
Okay. And Tiffany, does that make sense with the study that you designed?
I think so. Do you want me to send you a copy of the design that I sent that got approved, so you can use whatever information you need to off of it?
Okay. Okay.
I will email that to you.
Perfecto.
Awesome. Hey, thanks, guys. Keep us all in the loop for this information, and I'll see if I can't get this posted to a couple more sites. Okay.
Okay.
Okay. Sounds good.
More information. Okay.
Herman, are you posting it too?
Herman.
I don't know if he's frozen. Are you posting it too, Herman?
I gotta run, guys. Hey, thanks. Keep me posted, okay?
Okay, bye.
Okay. Thank you.
Herman, are you posting it?
I think Herman is out. So tomorrow, I think if we keep sharing the link, I think we can get at least 100 answers.
Yeah, I just posted it in an old school on my Pathway group Facebook page, and I know all of them will. And there's like 40 people in that group, so it should be good.
Okay, perfect. So tomorrow I can design the graphs, and I'll send a copy to you so that you can see if everything is right according to the professor instructions.
Okay. And I'm going to forward that information to you right now. So this is the design. Okay. Sorry, my computer's going super slow.
Don't worry. It is interesting for the data that we have with the 48 answers. 20% of the answers were people who grew up in a family with 4 children, and 25% of those 48 answers have 4 children in their own families. So
oh, wow.
At least by now there is a relationship between the number of children in the family they grew up and the number of children they have.
That's really interesting. This Google Doc that you did is awesome. It's fabulous. I'm so glad that you did that.
I think I have used this Google Doc a couple of times for my business and for my former job, and it is very simple, but it's very useful too.
Yeah, well, and it was really easy for people to do. Like, you know, as soon as I posted it, people were like, bam, they were on it. They were like, oh, okay, cool.
Yeah. It's very simple to use.
Cool.
Okay, Tiffany. So I'm going to check the study that you design and try to align this collecting data document to the study.
Okay, sounds great. If you have any questions, feel free to shoot me an email or whatever.
Okay, thank you.
Thanks, we'll see ya.
See ya, bye.